Okay, I want to take a minute to show you how to look for things like asymptotes on your graphing calculator. So what I'm going to do is I'm going to graph this. Now a couple things when I go to graph this, I'm going to go to y equals. And when I put this in, parentheses are your bestest friend. Put in parentheses. So I'm going to put the top in parentheses and then I'm going to put the bottom in parentheses. And I would highly recommend this because otherwise your calculator, obviously the newer calculators are going to do a better job. They tend to give you the actual fraction. So sometimes you don't need it, but it never hurts to have extra parentheses. Then I'm going to go graph this and I'm going to see what happens. Now when I look at this, I'm going to actually reset my window a little bit. I'm going to go a little bit big, a little smaller. I'm going to go say -6 to 6, -6, 6. Let's see if that shrinks it a little bit. Okay, now you could certainly use your trace function to try to find where these asymptotes are, look at it, and go, oh, I think they're there. But if you're not sure and you're like, I'm trying to figure out where these are, this is where your table function is going to come in. So above this graph button, this one here, it says table. I'm going to do second graph, and I get this table function. And you can see right there, 1, that's an error. That's a vertical asymptote. So when I come back here, okay, oh, I'm a graph. This right here, 1, this is a vertical asymptote because when I look at this, I get it. And I should also, if I come up here, see -1, that's also an error because those are my 2 asymptotes. Now, how about this one here? So the horizontal. So the vertical are pretty easy. They're going to be errors. Now, you can change the step of your graph. So like, for instance, if you think it's at a half or something, you can go to table set, which is the one above window. So this one here, table set. And you can have it, so I have it started now counting by 2s. You can count by halves. And now when I go back to my table, it's counting by halves over here. So you can change what X is counting by. So if you're looking for those. Now the other thing is I want to find the horizontal asymptotes, right? And now I think that's 0. How do I tell? Well, I'm going to come look at, again, my table. And what I'm doing is, as X goes to, okay, come here. I'll go back. I don't know what I'm looking at. So I want to know what point this is. What point does this never get to? So as I come closer and closer here in X, what's happening to Y? Where's Y going? So what I'm going to do is I'm going to go back to my table set and I want it to count by like tenths because I can see something's happening in there and I want to make sure I know what it is. And then I'm going to go back to my table. And so I can see as I come in, I'm getting really close to 0. I can see at 0, 0. This one actually does hit. It's not really a full, there's not really a full asymptote here. There should be an asymptote at 2. Okay, I'm looking here. So let's come back and look. Oh no, I want to see my graph. Okay, so this one isn't a full one. I can see that came in here. But what about this one up here? Well, this is 2, and I'm just looking at this. I can tell there's one supposed to be at 2. So, okay, how can I see that? Well, as X goes off here to either positive or negative infinity, so I can see that comes into 0, and that actually touches. So there's not an asymptote there. But, I was looking, never know what would happen. Didn't think there was, So, but up here at 2, how am I going to tell that? Well, I'm going to come up here. I'm going to put back my table to 1s because it's starting to drive me nuts. I come here, and I want to look, okay, and I need to start there so then I actually get it counted by 1s. There we go. So as this goes off to infinity, so you can see it getting bigger, 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 bigger. Notice this. It's getting closer and closer and closer to 2, but it's never actually hitting 2. Now, you might actually, if you go out far enough, see 2. But the idea here being that I can see that this is just going, closer and closer and closer, but it's never quite getting there. That's telling me, that's how I tell that there's a horizontal. So horizontal asymptote isn't going to show that error like the vertical will, but instead what it will do is it will show you that it's getting closer and closer. It'll show you that limit, that it's going to infinity. The other thing I want to show you cool is I'm going to change this, and I'm going to graph, let's see here, I'm going to graph something. I'm going to show you what a removable one would look like. So x, I cannot type, can I? X16 divided by x plus 4. So if I factored this, this would come out. So now if I go to graph this, this is going to graph as a nice straight line. But what was this? So the removable discontinuity here is at 4, right? I could get rid of it. So what at -4 actually. So what happens if I put in -4? I'm going to go to calc, and I'm going to go to value, and I'm going to put in -4. Look, nothing came up. That's that hole I talked about. It'll actually show it. So that's kind of cool, right? It does show the hole because it doesn't actually show a value there. Even though you'd think it would be 0, it's actually not going to show anything because it was that removable discontinuity. So just kind of thought I'd show you that. So we played around with it. You can kind of see how you're looking for the limits with the horizontals, but you're actually going to see the error with the vertical asymptotes. Just kind of goes, vertical asymptotes are easier than horizontal.